This video is for lesson 3 of the GCSE motion topic entitled Acceleration. By the end of the lesson, you should be able to understand what is meant by the term acceleration and deceleration, recall and be able to use the formula to calculate acceleration, and recall the unit with which acceleration is measured. Okay, before we start today's lesson, a quick review of what we did last lesson on distance time graphs. So what I'd like you to do is to pause the video, have a look at the distance time graph that you can see on the screen, and then try and describe sections A to D in as much detail as you can. And by that we mean calculating a velocity or a speed as appropriate. Okay, so if you'd like to pause the video now, we'll go through it in a moment. Okay, hopefully you didn't find that too difficult. If we look at section A first of all, notice that the line is straight, which indicates a uniform or constant speed or velocity. Okay, so that's the first thing we need to say. In terms of its magnitude, its size, the distance travelled is 15 meters, and it's taken 5 seconds to do that, so a constant or uniform speed of 3 meters per second. Similarly, B is constant motion or uniform motion. Its speed is slightly less, the gradient is lower, and the distance travelled this time is 15 to 20, which is 5 meters per second, divided by time taken 10, gives us 0.5 meters per second. C is nice and easy. There is no change in the distance from where we started from, down here, so the object therefore is stationary, and indeed stationary for 5 seconds. And section D, you'll notice that the gradient of the line is negative. In other words, the object is going back to where it started from. We can still calculate its speed by using distance travelled, 20, divided by the time taken, 10, which gives us a constant or uniform speed of minus 2 meters per second. Minus because we're going in the opposite direction. Okay, you guys now are of an age whereby in the next 3 years or so, if you're lucky, you might be considering buying a car. And I'd just like to run you through one or two of the factors which you might consider when you're doing that. The first thing, of course, is the price. Here you've got a Mazda 3 Sport, 21,000, an Aston Martin DB9 at 100,000, and more affordable for you guys is likely to be a Fiat Panda, £8,000. You might also consider the miles per gallon, how far you go on a gallon of petrol. 55 for the Mazda, a mere 22 for the Aston Martin, a whopping 58 for the Panda, so another good tick for the Panda. Top speeds, you can see 121 miles per hour for the Mazda, 190 for the Aston Martin, and a disappointing 101 miles per hour for the Fiat Panda. It's this last line here that I'd like you to focus on, however. Some of you will be aware of this. It's given in all literature for cars. And it's an indication of how long it takes a car to go from 0 to 60. So in the case of the Mazda 3 here, it takes 8.8 seconds from a standing start to get to 60 miles an hour. The Aston Martin, you pay that huge price tag for the speed and the time it takes to get from 0 to 60, a mere 4.6 seconds. And the Fiat Panda, your insurance will be low on this because of the time it takes to get from 0 to 60. Now, this measurement here, this time it takes to get from 0 to 60, is the car manufacturer's way of telling you the acceleration of the car. So the acceleration of a car is a measure of how quickly it can change its speed. And as I say, car manufacturers often use a 0 to 60 figure to give you some idea of the acceleration of the car. Now, when you take all those factors into consideration, you would of course plump for the Mazda 3 Sport, because everybody wants to be as cool as their physics teacher, don't they? Okay, so as you would expect in science, we don't measure acceleration in the time it takes to go from 0 to 60 miles per hour. It's impractical in a lot of situations. So we're going to discuss now what we do in science. So if you'd like to put the title Acceleration, this is all going to go into your notes. And the first thing is a little definition here. Acceleration measures how quickly something changes its speed or velocity, and it can be calculated using acceleration equals final velocity minus initial velocity divided by the time taken. Okay, so the speed that you end up with minus the speed that you started with divided by the time taken. That's one of the equations or formulae that you need to know and learn. The unit for acceleration is meters per second squared, or m/s squared for short, and I'll talk about why that is a little bit later. The triangle, a little bit more complicated because we've got this final velocity minus initial velocity factor in here. So I'll put that into the triangle there for you. Now, you can write the formula for acceleration in shorthand using the symbols here. So acceleration is equal to v is the final velocity, u is the initial velocity or starting velocity, and t is the time taken, measured in seconds. Now sometimes you may see it written like this. Sometimes to save writing out v minus u, we write delta v, change in velocity. We met that when we did specific heat capacity. Okay, so we could write acceleration as a equals delta v over time t. It means exactly the same thing, it's just a neater way of writing it down. Okay, you might like to pause the video at this point and jot down the notes on there. Right, I'm going to run you through a couple of examples now, and again this needs to be recorded in your notes. This will be really helpful to you when you do the Isaac physics problems, which I'm going to set you a little bit later. So a copy of that then please. The problem is a cyclist accelerates from 0 to 10 meters per second in 5 seconds. What is the magnitude or size of her acceleration? Well, first of all, we know it's an acceleration because there's an increase in speed going from 0 to 10 meters per second. So, as with all our mathematical problems, the first thing we do is we write down what we know using the symbols that we use. So the final velocity v is 10, the initial velocity u is 0, and the time taken is 5 seconds. Write down your equation, pop in your numbers, and write down your answer, 2 meters per second squared. Now, it's important you understand what that means. It means that for every second that the cyclist is moving, they are increasing their speed by 2 meters per second. So that is saying 2 meters per second, 2 meters per second increase in speed every second. Okay? Right. Number 2, a similar kind of problem. A car travelling at 32 meters per second slows down to 8 meters per second in 6 seconds as it approaches a set of traffic lights. Calculate the acceleration. Okay, now we're going to do the same sort of idea here, except making sure that we're using the symbols that we used earlier. So final velocity is 8. Initial velocity is 32, time taken is 6 seconds. Notice the final velocity, 8, is smaller than the initial velocity, 32. So it's slowing down or decelerating. However, we still use the same formula. A equals v minus u over t, which is 8 minus 32 over 6. Now if you put your numbers into the calculator there, you'll end up with a negative value here. Now what do you think that negative value is saying to us? Well, it's saying to us that first of all it is a deceleration. If you get a negative acceleration, the thing must be slowing down, decelerating. So don't be tempted to put the big number first in this formula here. It's important that you stick to the rules of final minus initial. And if you end up with a negative value, it means it's slowing down. Okay, pause the video and make a copy of that slide there. Okay, could you now go on to Isaac Physics if you're a higher level student, or Seneca if you're a foundation student, and complete the work shown. Please read the review carefully and make sure you understand all that's on there.